Hi there once again, hope you're doing well still. This video about solving trig equations is the second one, and it will really just focus on the process of using a calculator to solve trigonometric equations. Our last video was using the unit circle. We're not really going to use a unit circle here to solve anything. Just a calculator. I want to show you how that's done. So our first example will be a very simple looking equation there. 5 times cosine x equals 3, and of course we want to isolate the trig expression cosine x, and that's easy to do. You get cosine x equals 0.6. Now 0.6 is not one of the numbers on the unit circle like 1/2 or root 2 over 2 or one of those, but we can still kind of use the unit circle just to sort of illustrate where this angle might be. If you think about an angle that has a cosine of 0.6, that would be right about there in quadrant 1, and that x value being 0.6 also extends down into quadrant 4. So there's another angle down there in quadrant 4. So there's one in quadrant 1, an acute angle, and then another much larger angle down in quadrant 4. Both of them have a cosine of 0.6. So, like we said, that's not a unit circle number, so I can't just use the unit circle values to solve the equation, even though it's kind of nice to have a little sketch to get a picture of it. But we will have to use our calculator, and of course you know that if cosine x equals 0.6, then x equals the inverse cosine of 0.6. So we'll get our calculator out and work that out, and it's very easy to do. You just I'm using degrees here just to make some of the arithmetic seem a little bit easier. But x equals 53.1 degrees. That's just what the calculator says. So that clearly is the angle there in quadrant 1, and our sketch looks pretty reasonable there, 53 degrees. But what about the angle in quadrant 4? Our calculator is not going to tell us that. Okay? We have to figure that out. So how do we do that? That's the question here. That's what we're making this video about. Well, if you will look carefully there at the picture, you might observe that the angle between the x-axis and that quadrant 4 angle, that angle there is the same as the angle between the x-axis and the first quadrant angle. So I put the little black hash mark there on those arc arrows to show you that those two angles, one above and one below the x-axis, are in fact congruent angles. So this suggests, if you think about it a bit, that maybe all we have to do to find that other angle is take 360 degrees and subtract the 53, subtract the answer that we got from the calculator. And in fact, that is what you do. So 360 minus 53.1 is 306.9 degrees, and there's our answer. X equals the set of 53.1 and 306.9 plus 360k. Okay, and that, of course, as you may recall, covers the fact that there are literally an infinite number of solutions by going around the circle, let's say, more than once in either direction from these angles. Okay, so there's our method, and all we had to do was subtract our calculator answer from 360. Now let's try another one with a sine equation. This time, you know what, I'm just going to keep the answer, the equation numbers pretty much the same, and we'll just substitute sine instead of cosine. So there's our equation. Again, we isolate the trig expression, sine of x now equals 0.6, and once again the unit circle, if I just make a sketch of an angle with a sine of 0.6, it's something like that there, again in the first quadrant. And as you can see, there's also an angle in the second quadrant that also has an angle of 0.6. So we have two angles. Our sketch there shows clearly that there's going to be two answers to that equation. However, the unit circle does not provide those answers, so we use a calculator, and we use inverse sine of 0.6 on the calculator, and we get about 36.9 degrees. And then same question as before, how do we find the other angle? Well, if you'll look again closely at our little drawing there, the angle between the negative x-axis and that obtuse angle in quadrant 2, that red line in quadrant 2, that angle there is the same as the angle in quadrant 1. Okay, so with the little black hash marks there, I've shown you that those two angles there are congruent angles. Well, this suggests maybe instead of subtracting from 360 like we did for cosine, that we could find that other angle by subtracting subtracting the first one from 180 degrees, and that is in fact what you do. So 180 minus 36.9 is 143.1, and that is in fact the other angle that has a sine equal to 0.6. Okay, so that's pretty simple, really. There's our solution for that equation. Those two numbers plus 360k again to cover all possible solutions. So the next slide, I'm just going to kind of summarize what you do to find the other angle for a trig equation by using your calculator. Okay, so so the first thing to do is to use an inverse trig function to find your first answer. This is, of course, after you've done all the algebra to isolate the trig expression. So you use an inverse function on your calculator to find the first answer. And then, if your equation was a cosine equation, take 360 degrees minus your answer to find the other angle. Okay? 360 minus the answer. However, if you were using a sine equation, use 180 degrees minus your answer. And finally, we didn't talk about this as an example, but if your equation is a tangent equation, use 180 degrees plus your answer. So that's it. This is kind of a handy little summary of what you do to find the other angle on your calculator. And of course, if you're using radians instead of degrees, this is pretty common really, of course just remember to substitute pi for 180 degrees or 2 pi for 360. But you already know that. So you could put this little summary in your notes, I suppose, and I hope the examples were helpful in helping you understand why we do these little rules. And so now, thanks again for tuning in, and go do some math. Okay, bye-bye.